As we discussed in the previous podcast, there are two ways of describing instantaneous velocity and acceleration. We can take values of displacement or velocity at a given time and divide by the time at that point. Or we can use the second method I'll describe now. This method uses a principle derived by Isaac Newton and is a general principle of mathematics. You calculate the average property as we've described above, taking 2 points at a distance from each other, and you move these points closer and closer together. In more formal language, you decrease the difference between your points until there are no intervals between them. This process is called differentiation. For the purposes of this discussion, I shall simply say that the effect of shrinking the gap is to make the difference between your 2 points infinitely small and change the values of capital delta S or capital delta V and capital delta T to lowercase deltas. You simply work out the instantaneous property as we discussed before. This just gives us a mathematical principle we can apply later. Instantaneous properties are the same as average properties if the point at which you take your average is small enough. What you need to know is the results of all this work. Well, put simply, we have a way to work out the next level of equations from our graphs. From a displacement time graph, we can work out the values for a velocity time graph at the same moments in time. The velocity is the gradient of the displacement time graph. By rearranging the equation of velocity, we can also work out how to find out the lower order properties from a higher order graph. We can work out the displacement an object is covered from our velocity time graph by rearranging the velocity equation. Average velocity equals the change in displacement divided by the change in time. Therefore, the change in displacement equals the change in velocity multiplied by the change in time. In short, if you can work out the area under the velocity time graph for the times you have chosen, this will give you the displacement between these times. Again, we can use Newton's principles through his calculus to work this out, except here, instead of differentiating, we would integrate the equation of this line. In a velocity time graph, the area under the line is the displacement covered, and the gradient of the line is the acceleration at a given point. For a displacement time graph, the gradient is the velocity. For an acceleration time graph, the area under the graph is the velocity.